Thank you, Mr. Che. And our next presenter is Feng Guojie. He is the Senior Engineer, Deputy General Manager of BGE Environmental Restoration, and Mr. Feng, the Technical Leader of Engineering Projects, has been responsible for the implementation of more than 20 environmental restorations and government seed projects. In 2018, Mr. Feng was the facilitator of the National Key R&D project, and Mr. Feng has got 1 international invention patent, 5 invention patents, and more than 30 utility model patents, and published 5 papers. Mr. Feng was awarded Guangxi Science and Technology Award in the 2017 and 2019 respectively, and Science Development Promotion Award of Chinese Academy of Sciences in 2021, and the first prize of Guangdong Province Environmental Technology Programs Award. Today, he will give us a speech under the name of Waste to Energy, Technology and Engineering. Let's welcome.
好，大家下午好，非常高兴能参加这次培训。
Good afternoon, quite honored to join this training session to share and learn from each other. I'm from the BGE Environmental Technology. Today, I'm going to share with you the waste to energy and engineering case study. First, we know in our daily life, we're going to generate the waste. According to the statistics, we're going to generate 1 to 2 kilograms of waste every day for each individual. So before we are going to build up the landfill and so burn the waste. And also, sometimes we are going to do the composting. And nowadays, we have many incineration. And also, they are going to promote the waste for energy for daily use.
So in a very quick time, we can reduce the domestic waste for 90%. So for 5 people to produce the domestic waste, if we are going to use that for power generation, that is enough for the power consumption for 1 person 1 day. So in the last 5 years, including the 13th 5-year plan, which is 2016 to 2020, and the 14th 5-year plan, 2021 to 2026, the Chinese government have great policies to support. So we have planned to reduce the waste incineration capacity by 50% in the most municipalities in China, and to reduce and the waste incineration will account for 6% in Eastern China. That will be a total 580 1,000 tons per year. And by 2025, every day, China will be able to handle 800,000 tons per day. And for the urban domestic waste incineration, our capacity will be account for 65%. So we have some of the major technologies. So right now, the grate furnace is the most important technologies for the incineration. We are going to reduce the volume and we are going to better use the resources. So after incineration, the waste will decrease its volume and weight to a great extent. So as we are building the plants to reduce the household waste, there are some guidelines. For example, the Chinese government will encourage cross-region or cross-department collaboration, and we are going to develop more professional companies. And we are going to encourage the PPP model in the household waste treatment. And for the ground to incinerate or bury the waste, there are some requirements. And usually there will be 300 meters away from the incineration factory. We are not going to have any residential areas. But if it is more than 300 meters, there will be no impact to the neighborhood. So what kind of household waste can be incinerated? So there are some caloric values requirements. Generally, if we are going to put them in the furnace, the average low caloric value will be higher than 5,000 kg per kg. This will have a good result. And to select places to build the plants, there are some requirements. For example, they have to meet the general plan of the urban or rural development, and also they have to meet the environmental health plan. We also have to pass the environmental evaluation assessment. The second thing is when we choose the service area of this plant and what is the handling capacity for the collection, for the transportation of the waste, and also what is the future plan of the city, we have to make sure we plan everything ahead. And when we select the location, we will make sure that it doesn't affect any ecological resources, groundwater resources, airport, cultural heritages, or scenic areas. And when we build these factories, there are some guidelines to follow as well. For example, the engineering conditions, the hydrological conditions, geological conditions, and it should not be affected by any flood, waterlogging, or tide. And we will make sure there are good rules to drain the water in case of tide or flood. And between the factory and the service area, they must have good transportation facilities. And we have to consider how to handle the ash slags. And since people will be working in the factory, we have to make sure how to provide water for the production and for the life, and how to handle the waste water, make sure they are drained properly. And the next thing is to build a new facility, we must consider the power supply and all the other boundary conditions. Make sure the ground is leveled and all the resources or energies are available. And also we have to calculate how to produce how much heat will be produced and how to allocate them in the networks. Right now, for the amount of waste collection, there are some requirements. When we invest a new facility, it has to have the minimum amount of waste to be handled every day. In this way, we can have a good balance between the investment and the revenue. Right now, generally every day, it must can handle at least 400 tons. So if the city has more than 300,000 people, it is feasible to build a waste incineration plant. And based on the location, the scale, and also the expected revenue, we have to make a specific plan. For example, we have to coordinate with people living in the neighborhood to make sure they understand what's going on in this project and what will be the revenue for this region. And for the investment, we also have to make a budget. Generally, for every ton of the waste, the investment will be 500 to 700,000 RMB. We are going to build a factory with a facility of 400 tons per day. We have to invest about 280 million RMB. And for the power generation system, it had several modules. From this picture, you can see the relations. So there are 12 subsystems. First one is for household waste, the feeding system, which means we collect the waste from the residential areas or many different places in the city. We will collect them and transport them to here. So number one on this picture is the feeding system. Number two is the storage, the waste storage system. We can have some basic treatment here. For example, heat to increase the caloric value. And the third, number 10 here is the bucket, the grab bucket. It will put them into the furnace. So it will be burnt in the furnace. It will produce the thermal energy. Later, it will go to the steam generator or boiler. And this, so, and number 5 is the cleaning system for flue gas. And since there are some thermal energy in the boiler, it will go to a gas turbine system to convert this thermal energy into electrical energy, and it will connect to the national grid. And after the incineration, it will have some slags and ashes. And in this way, we can reduce about 90% of the volume, which means we still have a residual 10% that cannot be handled in the furnace. That's why we have to treat such ash or furnace. Right now, our company is working on this. For the ash and the slag, we are going to have a secondary utilization. And there will be very good economic value. For 1 ton of the ash, it will generate about the revenue of about 200 RMB. Next one is because there are some fly ash in the gas, we have to handle them as well. Some of them will be collected by the gas collector, but some of them will be solid and there will be a fly ash. We have to stabilize them. For example, around this area, we are going to build a facility to bury the fly ash. And number 7 is, since we store this waste in the system, it will generate some leachate. And this leachate can cause serious pollution. That's why we have to treat this leachate. It is a part of the water treatment system. And in the whole facility, since generally it is a negative pressure and it is not so well ventilated, while we're burning this waste, we have to make sure we get rid of the odor or any bad smell. So we must have an online monitoring for the flue gas or the odor, for the smells. And for the whole process, we have an automatic system, for example, monitoring or some other supervision facilities. to make sure we watch what happens. So this picture is a typical incineration plant for the waste. The layout will be like this. So just now, I talk about the 12 subsystems, and next I'm going to show you some specific pictures. First one is from the left part of the slide is the feeding system. After we collect the waste from different areas in the city, we're going to put them in this area. So they will go to the waste storage system. This is the cabin to keep this storage. And directly connected with this cabin is the furnace system. So when we go down, we can see the waste after burning, it will come to this step. And this is the cleaning system for the flue gas. Usually we use SNCR, the denaturation, and the semi-drying and active charcoal and drying method, and use bag collector. After all these steps, the flue gas will meet the national standards of emission, and it will not cause pollution to the environment. And while we are burning the waste, we have some thermal energy, and through a gas turbine generator, we can convert them into electricity. And this can be connected to national grid. And in this project, we can have many different ways of collaboration. In China, the most popular models are these three. The first one is the PPP, which means the government and some private companies will be partners. This is very popular in China. The second one is the BOT, to build, to operate, and to transfer. Example, after I build this project, I can run this project for 20 or 30 years. And after that, maybe I can transfer them to government or to another operator. The third method is build, own, and operate, which means I will always own this facility after I build it. It will be my asset. I will operate them for a long time. So for any potential project, we have to coordinate with government, make sure we understand the whole region. We have to analyze every day how many waste are produced, how to connect to the grid, and how many people will be working there. So we must go through a lot of assessment. This is a critical step. Make sure we have specific plan, whether we do it or not do it. This is a feasibility study.
And also we should consider the capacity of the local government, because in the process of the waste to energy transportation, we're going to get the subsidy from the government. For example, if we deal with 1 ton of the waste, we're going to get a certain amount of the subsidy from the local governments. So it depends on the financial status of the local government. So if these two conditions could be met, we could go on move to the next stage about how to build up. Then we're going to have the specific plan. Then also we have to have the cost under control. And also we have to know about the charge of the waste to energy process. So when we build up our incineration plants, we have to know the surrounding environment. For example, the money to buy the land or about the electricity fee. We have to consider all the factors related. And in recent years, we are promoting the classification of the waste. And also we have changed how to deal with those waste. When we classify those waste, we classify them into hazardous, recyclable, kitchen waste, and residual waste. If we're going to use the incineration, generally we use the residue waste. And also we know that the caloric value could be reached about 13,000 kilo J of per kilograms. And also we should reach the certain requirements. And currently we know that we have to reach the standard, and also we should keep the whole workload unchanged and well increase the efficiency, and for the sufficient incineration plant, and we should scale up and increase the capacity. And also, if you're going to have such certain liquid, you're going to have some influence of the waste and after the generation of the power. And if we could use the residue waste only, we're going to reduce the amount of liquid by 1/3. It's going to help us to directly reduce the cost of the waste. And also we couldn't reach higher level of the caloric value of the waste. If so, we're going to increase the power generation of the waste. If after the power generation we still have a large amount of the waste, then we're going to process that, and we're going to increase the cost. So we have to deal with this problem. And those are the basic specifications for the facilities. As you could see, those are the daily configuration of the incinerator, about 300 to 1,000 tons per day. And for the waste heat boiler, and we can use the medium temperature and the medium pressure, or the medium temperature and the secondary pressure. When we're dealing with the daily waste, we could also deal with other dried sludge. Those dried sludge could also be incinerated with those processed residue waste or the processed kitchen waste. But for sure, the amount of the kitchen waste and the sludge should be no more than 10% of the total waste processed. If we follow this percentage, they are not going to influence the incineration process. But of course, we have our worries over the doxing. And we hope that those doxing could be stay there for a certain amount of time. And for example, we hope that they could be incinerated for a certain temperature, and also the flue gases should not be there over 2 seconds. And currently, company has the all-in-one solution for the waste process. And as you could see, the whole campus has quite good greening. And also, we could provide consultancy, reform and upgrading operation management. And also, we have already bio drying pre-process. This is our core technology, and then it could keep the moisture rate of the waste at 20 to 25%, and also we could reduce the heat inflation and then reduce the powder in the incinerator. And also we have our catalyst for the development of the doxing, so we could decompose the doxing by 99% and above. And also we have our subsidiary called Tianjin Jiechuang. It could have the self-developed technology and provide the all-in-one solution. As you could see, this is the emission standard of our company. And currently we strictly follow the national policy, and also it is much higher than the European 2010 and then other related policies. Those are some of the case studies I'm going to share with you. And those are quite classic cases of the waste to energy. This is in Shunyi of Beijing. This is not built by our company, but currently it is under the management of our company, and we are responsible for its daily operation. This is in Sihong of Jiangsu province. It is in the Yangtze River Delta Economic Zone. It is also one of the important national projects. And we could deal over 400 tons per day. This is in Kezhou of Guangxi. We could deal with 900 daily waste. And this is in Houzhou Park of Guangxi province. This is Houtian of Guangdong. This is Hunan of Yueyang. Currently, this is the case shows the strongest operation capacity of our company. And we could deal with 1,500 tons and above. And it could deal with the kitchen waste and sludge. This is in Chunan of Henan province. Currently, it has been put into operation. This is in Jinghai of Tianjin. This is for the 2+26 corridor project. This is in Neijiang of Sichuan province. And this is one of the biggest waste-to-energy projects of our company. And we collect the waste and transport it. And we also have the terminal for the all-in-one solution. That's all for my sharing. Thank you for your listening.
Okay, so